So we're going to solve this problem. The problem says the base of a natural logarithms is e, which is a number of Euler, and is given by the value of 2.71, 82, 81, 82, 8, etc. The first one tells us, express e to 5 significant digits. So we're going to take into account these 5, 2, 4, 5 digits, but it is important for us to take into account this one, which is the sixth. So 2.71, 82, 8. Why it is important for us to take this last digit? Because this is the digit that is going to tell us if we are going to keep the same number or if we are going to approximate it to the next one. Why is that? Because if I have a number, for example 1.51, and the exercise or the professor or whatever tell us to take into account just the two significant digits, we have to take into account these two digits. So if the number that follows is between 1 to 4, we're going to keep this number because it is approximating to the same number. And if we have a number which is between 5 to 9, we have to, for example, 1.58, and the exercise tells us that we have to take into account the first two digits. It is important for us to approximate to the next one, to the next digit, in this case 1.6. So express e to 5 significant digits. This is 5, and we have to approximate 2 to 3 because of this reason. So the answer is, I'm going to write it down with red, 2.7183. That is the answer. I'm going to erase this. So determine the value of e to the second power to 5 significant digits. So in this case we're going to use a calculator because it is easier for us, and we're going to write down all the numbers because the exercise don't tell me that I have to use a significant amount of digits. I have to do it, but after I got the result. So it would be 2.71, 82, 81, 82, 8 to the second power is equal to 7.38, 90, 60, 56, 0.96. And then we are going to have to do the same with this amount of digits. And because we have a 0 but we have a 5, we have to approximate that 0 to the next number, to the number that follows. So the answer is 7.38, 91. That is the answer. Use the value of e you obtain in part A, which is this one, to determine the value of e to the second power. To determine the value of e to the second power to 5 significant digits. So we're going to write 2.7183 to the second power. It is equal to 7.3891, excuse me, 91, 5. I don't have to write it all. I don't have to write the whole number. So the first two, the second one, and the last 2 digits. So because we have a 5 right here, we have to approximate the number, the number that is right here to the number that follows. So the answer would be 7.3892. And demonstrates the hazard of using rounded off values in calculations. So we can demonstrate it, and we have already demonstrated that, but we just have to analyze it. And the answer is that we have here a mistake with these 2 digits, because the second one is different to the first one, and the first one is more accurate than the second one, even though we haven't used the whole number of e. This number is more accurate than this one. So that is actually the whole exercise. It was pretty easy. So